Welcome to this video lecture on the subject electronic circuits. In this lecture, we are going to discuss about BJT biasing methods. So first of all, what is meant by biasing? So the DC voltages applied to a transistor in order to turn on so that it can amplify the signal. So there are three regions of operation in transistor. So which is active region or linear region operation, where the base emitter junction is forward biased and base collector junction is reverse biased. And cutoff region, where base emitter junction is reverse biased and also collector base junction is reverse biased. And saturation region, where the base emitter junction is forward biased and base collector junction is also forward biased. So to operate the transistor in this particular region, we need to bias the transistor as per this condition. So there are different types of biasing circuits. So fixed bias circuit, emitter stabilized bias circuit, and voltage divider bias circuit. DC bias with voltage feedback. So fixed bias circuit. So in this configuration, it is the circuit is very simple, and also, but it has a limitation of the unstable condition. So for most configuration, the DC analysis begins with the determination of the base current. For the DC analysis of transistor network, all capacitors are replaced by a open circuit equivalent. So in this diagram, we have a transistor connected to DC power supply through the resistance RC, which is connected to collector, and RB, which is connected to base. And in this diagram, AC input signal is given to base and output signal is taken at the collector terminal. So this circuit diagram is a fixed bias circuit with input and output signal. And we can draw the DC equivalent circuit to analyze the fixed bias. So here the capacitor is replaced by the open circuit. So the circuit is drawn with the transistors and resistors and DC power supply. And first we need to calculate that to analyze the fixed bias circuit, we need to calculate the base current and collector current. So here the base emitter loop is drawn in this circuit, and we can apply the Kirchhoff's voltage law to get the base current. So by using Kirchhoff's voltage law, the equation is written as VCC minus IB into RB minus VBE equal to 0. So we can solve for base current from this equation. We get IB equal to VCC minus VBE divided by RB. So next, collector emitter loop circuit is taken. So here the collector current is calculated as IC equal to beta into IB, and applying the Kirchhoff's voltage law in this circuit, so we get VCE plus IC into RC minus VCC equal to 0. So from this we can obtain the collector emitter voltage is equal to VCC minus IC into RC. So next is the emitter stabilized bias circuit. Here we add a resistance RE to emitter circuit. So this is used to stabilize the bias circuit. So for analyzing the base emitter loop, we apply Kirchhoff's voltage law for this circuit. We get VCC minus IB into RB minus VBE and minus IE into RE equal to 0. So by substituting IE as beta plus 1 into IB, we get this equation. So to obtain the base current, we have VCC minus VBE divided by RB plus 1 plus beta into RE. So this RE is used to stabilize the current. For collector emitter loop, we consider the collector emitter circuit and apply Kirchhoff's voltage law. So here we get IE into RE plus VCE plus IC into RC minus VCC equal to 0. So in this case, emitter current is nearly equivalent to collector current. So here we get the collector emitter voltage. So also emitter voltage equal to IE into RE and collector voltage equal to VCE plus VE or VCC minus IC into RC. We can also obtain the base voltage VB as VCC minus I into RB or VBE plus VE. In this we improve the bias stability. So stability refers to the circuit condition in which the currents and voltages will remain constant over a wide range of temperatures and transistor beta values. So stability refers to the stable current. So adding Re to the emitter improves the stability of the circuit. So here in this beta values are given, and also corresponding IB base current, collector current and VCE voltages are given. In the second condition were fixed by a circuit, the beta values 75 and 100, current values are tabulated. So we can check these two conditions for emitter bias and fixed bias. There is a fairly constant values are obtained in this. So let's take the assessment. So discuss the disadvantages of fixed bias circuit. So in the what we discussed in the fixed bias is the circuit is simple, but it has a limitation of unstable condition. So stabilization is poor as heat development can be stopped. So the stability factor is very high. So there is a chances of thermal runaway. Thank you for listening this lecture.